So take a breath. Think about it. Where does your oxygen actually come from? Of course, it comes from photosynthetic plants or photosynthetic organisms like plants, but probably what most people are not aware of is that most of what you breathe actually comes from the ocean. It's been estimated that 2 out of every 3 breaths you take comes from the ocean. Similarly, the largest natural carbon sink on Earth is actually the ocean, and that absorbs significant amounts of anthropogenic carbon dioxide emissions. But our coastal vegetated habitats, things like our mangrove forests, our seagrass beds, our salt marsh or samphire habitats, have often been termed blue carbon habitats. They're extremely efficient at capturing and storing carbon and often referred to as carbon sinks. For that reason, they're particularly important in helping to combat climate change. So what this figure here shows, if you focus on the 3 habitats down the bottom, those are our blue coastal carbon habitats. And what you can see is that they're able to accumulate carbon at much faster rates and store it for longer periods of time than our terrestrial habitats that you can see up the top. They do this through photosynthesis and absorbing carbon into both the living and the below ground material. And you can see that here in terms of the mangroves and the amount of living material. Just see if I can do it up here. The amount of living biomass relative to the soil organic carbon. But they also capture material that's coming through those habitats and incorporate it into the soil, as you can see here. The tides move in and out over these habitats, keeping them wet or submerged, and what this does is slow down the bacterial action and the degradation of the carbon and in order for it to be incorporated into the soil. So these habitats provide a very effective solution for carbon capture and long-term storage, and they're therefore well suited for climate change mitigation strategies and policy efforts. These diagrams help to show that. Basically, if you focus down the bottom, you can see that when we lose some of the above ground material in those blue carbon habitats, we also reduce the amount of carbon in the soil and emit CO2 into the atmosphere. In contrast, if we focus on the top diagram, we can see that if we restore, we create, we conserve these coastal carbon habitats, we're incorporating much of the carbon into the sediment below. Further, these habitats have additional co-benefits, things such as being able to regulate or stabilise soils from storms, etc. They're also important nursery habitats that contribute to our fisheries production. So we can see that we've got enormous benefits from being able to ensure those are healthy, intact habitats. When it comes to carbon crediting schemes, Australia actually has a huge ability to act here. We have some of the largest blue carbon habitats in the world. We have a means in terms of being able to incorporate them into some of the carbon credit schemes, but we need to be able to demonstrate that it's more than just a business as usual situation. We actually need to be able to demonstrate that the carbon that we're using in these schemes is additional to what we would otherwise have. And we also need to ensure that it's retained long term. So there's several approaches that we can use here. The first is to ensure that we enhance carbon sequestration through rehabilitation of disturbed sites. And the second is to avoid greenhouse gas emissions by protecting these habitats from any future development or future, for example, or future means of being damaged. And both of those approaches are possible, but the viability of each depends on the extent of the area that you would be protecting and also the future price of carbon credits. One area that's particularly promising here in South Australia and is seen as very viable both here and internationally is the reintroduction of tidal flows in drained habitats to restore the blue carbon habitats. And there's currently trials underway at the old Dry Creek saltfield sites investigating this further. So I'm just going to leave you with this slide to ponder. It comes from the Nature Conservancy and it sums up the benefits of some of these coastal carbon habitats relative to some other industry activities. Thank you.
Thank you, Bronwyn. Your question that you've chosen from the audience tonight is how might climate change affect fisheries and aquaculture?
Thank you. In terms of fisheries and aquaculture, Australia has some of the greater levels of per capita fish consumption in the world, and you can see that here in this diagram. We're not as high as some countries, but we're certainly significantly higher than others. From a lot of studies, the focus has been on invertebrate fisheries being negatively affected rather than, say, some of the finfish species, and there's been considerable work looking at range extensions of species, how they might adapt to a changing climate. But we also can start to look at how to reduce the fuel use and the greenhouse gas emissions in some of these fisheries or aquaculture ventures. And one of the most promising ways is to reduce vessel emissions, and it's been estimated by up to 10 to 30%, is to consider modifications to vessels, things like increased propeller size, to think about more efficient boats in terms of hull design, reducing the speed of boats, etc. But there's also approaches around changes to fishing gear, changes to technology that's used in fisheries, as well as shore-based facilities and changes in the aquaculture industry. But another approach is to think about fuel use and greenhouse gas emissions in terms of some of the management strategies that are actually put into fisheries and aquaculture. So I was just going to conclude with this slide here. There's been a recent study that's looked at environmental costs of aquaculture, fisheries and agriculture, and these three slides here sum up some of the potentially more beneficial in terms of environmental effects based on greenhouse gas emissions. One of them is the small pelagic fisheries, because you're capturing a large number of fish for very little effort relative to some species. Another one is bivalve farming, so things like mussels, where essentially you've got them out in the water using very little energy. They're basically filter feeding what's there. And the third one is salmon farming, where again we've got quite high feed conversion ratios. We're not having to pump water, etc. through. So there's options there around how to reduce our greenhouse gas emissions, etc., around fisheries and aquaculture.